So looking at some problems and questions, examples of arithmetic involving complex numbers. So yeah, we're looking at putting all our answers in the form x plus I y, x and y being real, so we're getting a complex number. So this time we've got the multiplication of 7 plus 3i times the conjugate of 4 minus I. So we've got to do a situation first where we change to the conjugate there, so it gives us 4 plus I. Then expand it out, remembering that we're going to get the 3i times I, which is 3i squared, which is going to be a negative. So 28 minus 3 gives us 25. Add the 7 and 12 gives us 19. So 2 minus 5i over 4 minus 3i. Again, we can't do the multiplication, the division there, so we multiply by the conjugate of the denominator. Using this idea again, multiplying a number by its conjugate gives us a real number. So it gives us 16 plus 9 on the bottom, expanding our top one and collecting our terms there. So find the square root of 9 plus 40i, so values of a and b all squared there. Again, remember, expand it out, a squared minus b squared, 2abi, and equate our real parts and our imaginary part. So the 2ab is equal to 40, so we can write b as 20 on a in the end. Do our substitution into the a squared plus b squared minus b squared. Again, we're going to factorize we're going to expand it out, multiply this by a squared, factorize, so we get a squared minus 25 and a squared plus 16 is equal to 0. Again, we're going to ignore the a squared plus 16, just take the a squared minus 25 because a's got to be a real number. So a can be 5 or minus 5, b would be 4 when a is 5, or b is minus 4. So there's our solutions. A is 5, b is 4, a is minus 5, b is minus 4. Again, same process. So we're going through, expanding our left hand side, equaling the right hand side, and then we're finding the values there. And again, go through the process, ignoring the a squared plus 1, and we're just going to get down to 3, 1, minus 3, 1. So there's our two complex numbers that we get. From the first part, there, we're going to use obviously this part to use it to solve here, because if we got complex coefficients, put it into the quadratic formula, take a lot of care. Obviously that's not an easy expression, so you've got to be really careful with what you're doing there. So we get the problem, we get it down to 2 lots of 8 plus 6i once we do our factorization, and so we can cancel our 2's. Remember, the square root of 8 plus 6i was plus or minus 3 plus I from the first part. So it'd be plus 3 plus I and minus 3 plus I there, and we're able to get our solutions. Find the square root, again, same process there. 5 minus 4, have a look at the process, come down and get your solutions to that part. And again, we're going to use it in this part because we've got the square root of 5 plus 12 minus I. So we're going to use the solutions there. We had 3 minus 2i and the minus 3 plus 2i. So it comes down to those two. That were our two solutions that we put in there from the previous part. Now, what we want to do, and we're told that it's purely imaginary. So when we get our solutions here, we've got this one, we have 1 minus 3i and 2 and minus I. So what we're going to do is ignore this one, because that's not purely imaginary. That's got a real part and an imaginary part. This is purely imaginary because there's no real part. It's just an imaginary number. So there's no real part to it. So if this is purely imaginary, basically it's saying, well, it's allowing us to discard one of the solutions and only take the one. So if that's the case, z's equal to either that one or I, and it's purely imaginary, so it must be equal to I. Find z to the power of 400. So remember what we did before when we looked at these solutions. We look at the idea that I to the power of 4, well, I to the power of 400 is I to the power of 4 times 100 using our index laws, and I to the power of 4 is equal to 1 because we looked at that before. So 1 to the power of 100 would be 1. So if it's purely imaginary, z to the power of 400 would be equal to 1. So there's a little trick with that question there. So you've got to be reading what was in the problem of the idea that it's purely imaginary. And question 6, a simple one to finish with. Multiply again. Really pay attention to this idea when we multiply a complex number by its conjugate. We're going to end up with the addition of the two squares there. So 9 plus 4 gives us a 13, and w is 4 plus I, so 1 on 4 plus I, multiply by its conjugate to give you that number, to get that solution there. Okay, so there's some examples of what happens with arithmetic of complex numbers. We'll do some problems during the week, and hopefully we'll start to get very confident with all this work.